So my name is Paul Lacey. I'm the head of product marketing here at Ascend.io, and pleasure to be with you today. I'm going to be sort of running around in the background, answering questions, helping out with the lab today. But our main speaker is Mr. John Osborne. John, welcome. And would you like to introduce yourself, John? Say a little bit about your background.
Sure. Thanks, Paul. My name is John Osborne. I'm the field CTO here at Ascend. So I get the lucky job of evangelizing data pipelines and our data plane partners and doing fun things like this, aside from my office taking care of technical questions with customers or in the pre-sales realm. And I particularly like, if you follow me on Medium or whatever, or my Ascend blog, talking through strategic topics like adoption and like how do you go postmodern data stack, and how do you do kind of really interesting build buy decisions, and why you shouldn't build your own data stack and those kind of things. So if you're interested in that kind of stuff, feel free to hit me up over there, or Twitter, or I'm pretty easy to find on LinkedIn. So nice to meet all of you.
And John, I will say to the folks on the call here, don't let the CTO title fool you. John actually writes code all the time. So one of the things I love about working with John is anytime we got some things we want to look into or tests we want to run or stuff, he's always like, "Oh, let me at it." He's going to go write some code and deploy. Yeah. Despite the fact that, John, I think you describe yourself as a recovering CDO. Is that right?
So I am a recovering CDO. I have many a road rash from that experience, and I wish I'd had Ascend. In fact, one of the reasons I joined Ascend was because I think Ascend solves tons and tons of problems that a lot of CDOs and CTOs have in the data world. So that was sort of the most recent part of my journey before Ascend.
Awesome. Yeah. And it's also great to hear the experiences you've had managing some pretty large teams of developers working on data and stuff like that. I know when we get a chance to sit down and grab a beer and stuff, John, I always appreciate that too. So just a little bit of color for everybody in terms of your background, which is great. And I guess we can go ahead and jump into the lab, right, John? So talk about what we're going to get working on today.
Yeah, sure. So it's a pretty casual agenda, I think. What we're going to do is go through a little bit of how to set up an account on Ascend for free. Our single dev accounts are free. So if you bring some Databricks credentials, and you can set up an Ascend cloud account, and you can start using Ascend in a few minutes. Aside from that, the next couple of things are we're going to talk through some simple data flows we're going to build on the fly here. The directions are all online, and I'll lead you through it. So if you're going to follow along, clicking and typing on your own, that's awesome. If you want to redo it later or re-listen to the webinar, I'll show you where all the assets are. But we're going to ingest some data super quickly into Databricks. Then we're going to do some transformations, which is our word for adding business value to your data after you ingest it. And then I assure you that all this work you're going to do is actually going to automatically register with
Unity catalog.
So I'll show you how that gets configured right at the beginning when we start. And the rest is sort of hands-off as far as Unity catalog goes until you want to use Unity in the Databricks way. So I think that's a pretty good agenda. What do you think, Paul?
Yeah, that sounds great. Let's talk about step one, which is getting set up.
Yeah, so step one, I'm just going to go over here to Ascend.io, and we're going to see this create account button up here. So for those of you that haven't done this, this create account is really easy to use. If you have a Google, lots of people have Google accounts that can authenticate with. We also support GitHub and LinkedIn. And then if you do that, I actually can't in this session because of I'm already logged in. But if you go to the next step, it'll allow you to put in some basic information and then get the account set up. And then you'll be able to put in your GitHub credentials and stuff. So, or sorry, not GitHub, Databricks credentials, and get connected to your data source. That ends up looking like a connection into your Databricks account. And then from there, you can start to build pipelines. So it should be self-explanatory. It should be really easy to do, and because it's designed to be easy. And if you don't have a Google account, you can try GitHub. Most people have both of those. LinkedIn is also possible. So that's as easy as it is to set up a Ascend account. And I want to note too that those Ascend accounts can then be escalated. So if you want to actually do real trial activity with your business data, or we want to convert that account to like a business account where you enable the extra security features and stuff, like that's all super possible. So just wanted to point that out too.
Yeah, and I guess also great time to give a shout out, John, for folks who are on the call. If you run into any issues, please go ahead and put those into the Q&A part of the platform, and we'll get to those right away. So we'll be able to message you, and we can help you out as you go along here. So if there's any questions that come up, if you just want to follow along and watch us do the work, you certainly can. But if you're here to do the work yourself, then that's what we're here to support. So please take advantage of that and ask us questions and things like that. And we'll be more than happy to make sure you leave here with a running version of your code. It'd be great.
Yeah, absolutely. No doubt on that. Let's assume you have an account set up. If you're in process or you're already done with it, and let's build some pipelines. So the first thing I want to point out here when we're talking about this particular webinar is that we have a really nicely designed developer datasend.io site. This has all the documentation for the API and all kinds of stuff, but it also has the documentation for this webinar that we're going to follow. So if we click here, the easiest way to nav is to click here on documentation. And then there's a quick start guide here. So we're going to use this quick start guide to create a couple of domains of data and potentially a data mesh if you're interested in that. For sure, we'll get through the taxi domain here in short order. Maybe that'll generate some questions, and we can keep moving and build a whole mesh. An experienced user can do the whole thing in like 10 minutes or so. We'll be going a lot slower so that we can point out some interesting things about Ascend. So as far as Ascend goes, this is where the documentation is, and so if you're going to follow along after, this is where you go, and the instructions are pretty easy to follow for sure. So let's get started. What do you say, Paul? This is the Ascend platform. I have an admin view, but I have a data service here that would have been configured for you automatically when you log in, and this is the webinar data service. This data service is hooked up to Databricks. That you'll also get this automatically when you create your Ascend account using Databricks profile. This connection will connect to your Databricks instance. This one connects to my instance, of course. And I do want to point out down here, this is the Unity catalog name that this data service is going to write to. You can have any number of data services. Therefore, you can have any number of catalogs. But when we create the data, it'll get published into the Unity catalog we put here. So I'm just going to call this webinar. If you don't supply a catalog name, then you won't be using Unity catalog. So I'm going to just update that so that we have that. So the very first step in the process here is to actually create a data flow. We call data flows our collections of components that do ingestion all the way through delivery, and we group up those data flows into a data service. So the data service is responsible for the Databricks connection and sort of the high-level things like what are your naming conventions, what's your clustering like in the Spark side of ingestion, and then how do you make your actual connection into Databricks. So I'm going to create a data flow here, which will again, when you sign in, you'll have a default data flow that gets created. I'm just going to create one for this webinar really quickly. Just call it webinar. I'm going to add just a little description, and I'm going to create it here. So because I created data flow, there's nothing in it. It's blank. So now we have a blank slate to get started. So what I'm going to do though is I'm going to pause my share and share two screens so that we can follow along both things at once. So anyway, let's create some data. So we're going to create a read connector here in Ascend. It's super easy. So I have my data flow. I'm going to create a read connector. I'm going to add a connection to an Amazon S3 area. So I'm following the instructions here. We're going to make it read only. The connection name doesn't matter other than we're humans, so we like names. So we're going to do that. And our default bucket is this one. It's a public bucket, so I don't need any credentials, which is great. And then it's a standard connection. So I'm going to hit test here. Test connection is really useful because it validates that the connection configuration works. So, and then we're going to hit create. And that's a simple process to create a connection. Now we can use this connection. So these connections are reusable. I can use them as many times as I want. So anything in this bucket that I want to read, I can read out with multiple connections. So we're actually going to use this connection to pull in some data. You can see I get a browse view here, which is useful in some areas, but I'm going to actually skip and configure manually here because I really want to create a green cab data ingest. So I'm going to ingest some green cab data. So we're going to call this the green cab ingester. So I'm going to change the name here. The name's important because it shows up as a database table in Databricks. So having the name correct will make the SQL statement work that we're going to cut and paste. So that's important. The bucket is the default one, but I do want to do some regex matches because I want to load more than one file at a time. So we're going to load all of this green cab data with a star.csv at the end, or actually a .star.csv at the end. And we know it's CSV files, so I'm going to use a parser, and they have header rows in them. So I'm going to check the header row. So that's as easy as it is to set up what to ingest into Databricks using Ascend. The next great part about Ascend is that the schema portions are automated as possible. So what Ascend is going to do is going to reach into the bucket with the connection. It's going to pull a limited amount of assets out, and it's going to do some sampling to try and figure out what the schema is. So you can see that longitude and latitude are doubles, passenger counts are integers, that kind of stuff. So I have my schema ready to roll here. If I want to add quality checks, I could, but I'm not going to do that at the moment. We'll do that later. So I'm going to create this connection. And then a bunch of things are happening in the background. One is Ascend is going to read the bucket, and it's going to load the data from the bucket. And then once the data is loaded into a stage area for Databricks, it's going to put the data into Databricks automatically for us. While that's going, we're going to use the same connector here, and we're going to create a yellow cab connector. So I have green cab data, and I'm going to have yellow cab data. This one's going to reuse the same connector here. But I'm going to use a couple different configurations. So we're going to copy the name and put that here. Again, the name ends up being a database table, table name. I'm going to use a prefix match this time. So I want to load all the files in this particular directory. So yellow cab data in this directory, I want to load them all. That's what the prefix would do in an S3 bucket. I know there's CSV files, and I know they have header rows. And I know this data is poor data, so I'm going to make this permissive mode ingest. Sometimes you have data that you want to be perfect. So fail fast is great for that because Ascend will stop ingesting data if it encounters errors. In this case, I want to ingest data even if there are errors. Those errors, if I choose to keep them, can be sequestered into a corrupt data column if I choose. So I'm going to ingest in permissive mode. Again, the schema operations are automated. So this schema is slightly different. There's a couple different column names, but in general, Ascend's going to work the schema out just fine. So we're gonna create this connector also. So yellow cabs is going. Just see what is going on here. Oh, my catalog. I didn't create the catalog. Let's edit that real quick. Let's take this out just for a second. And we will refresh these. Just to get the data ingested. We'll come back to the catalog later. So then if I have this data and it's being read into Databricks via Ascend, we're going to load all those records. We're going to create the, we've already created a database and a table with this name in it, and we're going to pull the data in, and it's going to be up to date. In this case, there's 5 partitions because there's 5 files. The yellow cab one, there's only a single file, so it's a single partition. The next step in the process would be to actually join these two data sets to create a data set that's all of my cab data. So let's do that. We're going to create a new transform. There's many ways to create new transforms. I'm going to click there and do that. And we're going to call this the all cab data transform. And because we're using Spark, I'm going to copy the Spark SQL. We support Snowflake and BigQuery also, and the syntax is slightly different. So we're just going to use the Spark syntax here. And I'm going to paste that so I don't have to copy and paste it. Notice I have cab color here for yellow cabs. I have a union with the green cab data, and I'm going to call this green cabs. So that's how we're going to execute that. And then I'm going to actually reduce all the partitions to a single partition in this case, as just by default. So you can see here on the left side, we have 4.6 million records that we've ingested here. We have 234,000 records in yellow cab, and the all cab data join is going to happen. I wonder if I have a syntax error here. We're going to look. Trip type, yep. We're going to change that real quick. Trip type underscore. I actually knew that was going to be a problem. There we go. Notice I get type ahead, by the way, in the editor. So as you're typing, you know that there's fields available. I actually have to change that. So we're gonna do that, and then total amount down here has the same problem. Sorry, let's see, total amount underscore. There we go. We'll update that. Okay, so we have our all cab data schema that we created and our join query, and you can see that again, quite a few things are happening. One is the data is ingesting into this table. We're running this query in using Databricks SQL, and we're creating this table all automatically in Databricks. The next step in the process here is to create the this control cab data. So this is just another transform to demonstrate how to create downstream transforms. I'm going to collapse this box in Ascend. So if I create yet another transform in Ascend, I can give it a name again, and then I can use my my Spark SQL statement, and I can create additional schemas or additional things. So in this case, I'm creating a arrive date out of a date time. There's a new column in here that's also getting created, and I can add whatever I might like too. So just add webinar type, for example. So I can add and do whatever I need to in these queries to add value. So I can go ahead and create that. Go ahead and create that transform. This transform had the job of getting ride dates out of ride date times. I could have done that over here too. These two statements could be combined, but we're making them separate to make it simpler. The last step in the process here, because we're building a data mesh, would be to create a data share. And that's just as easy. Sharing data in Ascend is as easy as just creating a data share like this, where I can have my data share name ends up in a catalog that you can share from in Ascend. And then I'm going to let all services have access to this. So I'm going to just create a data share like this. So just in those couple of minutes, aside from the little SQL statement issues, which everybody has, we created not only ingestion of 5 million records or so, but also went through the pipelining of adding some value and doing some data, basic data wrangling, and then culminating in a data share. So we called this our taxi data for a data mesh. So that's where we are with that. The next step in the webinar flow would be to create a weather domain. So we have taxi data and then we have weather data. So we can create that in the same data flow, or we can create that in a new data flow. This is an organizational strategy for how you want to manage your components and your flows. I prefer to have separate data flows for separate artifacts. So if this is taxi data, I actually want to create I'm going to call it a webinar weather data flow, and I'm going to create my weather data flow in a different weather data flow in a different data flow. So you can see I have my original one here and I have my weather one here, which we're going to create in. I do get to reuse the reconnector even in a different data flow, so I can reuse the sample datasets connector. Again, I'm going to skip in configure manually and call it some raw weather API data. We happen to have a file out here in the S3 bucket that has raw JSON data in it. That's this file here. So I'm going to load this API data. This is JSON data that got loaded from an API. It's actually a CSV file, and it has a header row. So I'm going to check those, and I'm going to generate schema. So notice this schema has a single column. It's the HTTP response, and you can see the data here is a string, but the string is a special string. It's JSON. It's JSON data. So whoops, I added another column by accident. So we're going to go ahead and just ingest this HTTP data as raw data. This could come in on a stream that you read into Databricks using Kafka or something using Ascend. That's super easy to do too. But for the time being, we're going to read that in, and I'm going to make sure this HTTP response is not null, just for fun. So I'm going to add a quality check. That's not in the webinar flow, but I'm going to create it anyway. So now we have some raw API data coming in. It'll be ingested just like the other ones. I'm reusing the connection, so it's super easy. But now we need to actually read in some more data that has like weather station name. So in the raw data, I have a weather station ID. I actually want to read weather station metadata in, for lack of a better term. So let's create a weather stations read connector. So I'm going to use this connection yet again. I'm going to call it weather stations, and we're going to read from, we're going to use an object pattern of stations with a prefix. And we're going to use a CSV parser again. CSV seems to be like a ubiquitous format to load. So we're going to do that, and we're going to see that we have a weather station ID, which is great. We have latitude, longitude, and we have a name, so that's great. So we have weather station name. So if we're building a report, we're going to have some weather station name data. Then I'm going to ingest that. So this data and this data, though, isn't really useful until we join it. So let's create a couple transforms. The first one is we need to explode the raw data into something useful. So this is JSON data that we're going to explode. So let's create a new transform here. We're going to give it a name called parsed weather data. Again, that's a table name, and I'm being adamant about the names because I'm cutting and pasting queries that depend on the names being correct. So we're going to use this query here to take the raw HTTP response data and do a from JSON on it. So we're going to read in the data into a JSON document, and then we're going to use Databricks syntax to create this. So we're going to create this as Databricks SQL. I could just as easily do this in PySpark, by the way, using Databricks Spark also. So if I created a new transform here using PySpark, I could write PySpark code to do exactly the same thing, but do it in Spark syntax. I could do either. I don't have the code for that to cut and paste, but nonetheless, you can pick and choose between them, and you can go back and forth between SQL and Python. Anyway, I have the parsed weather data. So now what we want to do is create what we're going to call a clean weather data. So I'm going to take this weather station data and I'm going to take this parsed weather data, which has a schema here, and we're going to join these two data sets together. So we're going to call that clean weather data. Again, I'm going to create a new transform here. Notice I did that a different way. Oops. We want our clean weather data name here. And then we're going to use this this query here, which is a query that's going to join the parsed weather data together. Oh, I'm sorry. This is just a group by select. So we're going to create the clean weather data out of the parsed first. Sorry, I got ahead of myself there. We're going to build the clean weather data. Now we're going to join the weather data with the station data. So let's create another transform here. We're going to create a new transform. This one's going to be called weather and station. And then, of course, we have our query here that we're going to copy and paste in, and now we have a join between the clean weather data and the weather station data. Notice the ID needs to be changed, and notice that I have full fidelity access into the Databricks SQL API. So I can use functions, I can publish my own functions, I can use existing ones like NVL and concat here to create the join statements that I need, or whatever data cleaning I need, for example. I get full fidelity access to it. And then notice what the platform's doing here. It's actually updated the DAG a few times. So our DAG is getting built. This is all up to date. And the platform understands that this particular weather and station query is dependent on these upstream activities. So if I were to edit something here, let's say I change, let's say I add a column, for example, and my schema changes, for example, the platform's not only going to rerun this query, but it's also going to do the downstream queries too. So I just wanted to point that out, that Ascend is automating all of this. I didn't need to go to an Airflow. I didn't need to exit my DAG engine to go do something else to kick a job off or do anything like that. Ascend is doing all of this automatically for you. And then the culmination here, just like the other flow, we want to create a share. So let's create this mesh domain weather data share, and we're gonna just create a new data share here because we want to publish it into our Ascend catalog, and we're gonna create it this way. And then because we also have the Unity catalog configuration, all of these tables will end up in Unity catalog, targeting the catalog that we're gonna create. So if we continue this demo, we now have two things. We have our taxi data, which is here in the webinar flow. We have the weather data, and what we're really building is a mesh. So the next step would be to actually produce a product out of our mesh, one being a combination of the weather and taxi data. So let's do that real quick, and I'm gonna do that in a new data flow so that it's clear what we're doing. So if I was for example, an analyst and I wasn't part of the engineering or the ingestion of the data and I wanted to build a report, this would be one way to think about how to use Ascend for this. So when we do this, we import or connect to data shares. And again, I have a view over the whole catalog here. But because we're doing the Databricks webinar, the things that we've been publishing are going to be in this Databricks webinar category. So I'm going to grab my taxi data. I'm going to subscribe to that. We're just going to create that, and then I'm going to connect to my weather data also. So I'm going to subscribe to both of these data shares. So now I've started a flow, but I've started a flow not with ingesting, but with using shares. Interestingly, if you have more than one Databricks account or more than one Databricks environment, the shares will cross Databricks environments. In fact, if you're pulling data maybe out of other data planes like Snowflake or BigQuery to do analysis in Databricks, the sharing also works across those data planes. So you can share data from Snowflake into Databricks just as easily as you can within Databricks. But now that we have these two shares, we need to do something useful with it. So we're going to go over here and create another transform that joins these two. Or actually, we're going to create unique weather by day, actually. So we're going to use this mesh weather data, and we're going to create a transform that creates unique weather by day. Oops, I'll paste it there, and I'm going to grab my my Spark query, and I'm going to create a query here that does that creates the unique weather by day. Notice I'm using a partition by query here. Again, full fidelity access into the query engine, both in SQL and Spark worlds, so they both work equally well. Both are pushed down into Databricks anyway. It's just a decision of which compute engine you want to use and what language you want to use. So the second to last, or the third to last step here is to create a weather and rides join. So we're going to join this one and this one. So this is going to join. This is the first time we're actually going to join our taxi and weather data together. So let's do that. Again, creating a transform is super easy. I'm going to call it weather and rides, and I'm going to grab my Spark SQL syntax here, and we're going to create a join. So let's talk about this just for a second. I have the taxi data here, and I'm selecting all those columns. And then I want the weather type to come out of my unique weather by day. So that way it'll be like a rainy day or a not rainy day, for example. So let's create this. And now you can see the DAG is updating, and all of that's working great. And you can see that I have unique weather and taxi data creating a lineage for this flow here. So we're creating that. And then the final data product are simply different versions or different shapes of this data that we're going to publish for consumers. So, for example, let's create a transform that has bad weather rides. So this is data that is the weather rides that are only have days that are actually these are good weather rides, but not rainy or not rainy. Yeah, so it's bad weather data. So we're creating bad weather data here. I need to change the name here. Weather and rides. There we go. So I have bad weather rides here. I can create all rides with weather. That would be nothing more than doing a new transform that selects everything. So we're just going to do that. So this is all rides, which is of course all rides. And you might do this just to change a name or to apply different security for people who are coming in to look at this data. Then you may hide this table and unsecure this table. That would be fine. And then the last one is a good weather ride. So this is the opposite of the bad weather rides. Well, in this case, let's create it with a more friendly name. We're going to use good weather rides with spaces and stuff in it. And in this case, of course, we're going to pick where weather is not rainy. So good weather. And we're going to use our case sensitivity here, and we're going to create that. So what I've created now is 3 data products in the as outcomes in different shapes of this data. Oftentimes, folks using this type of engineering might take these 3 things and put them in a BI tool where the logic resides. The tricky part of that is that these particular fields are the text of not rainy is owned by this data flow. So I actually want to create these shapes with that data from these flows so that the business logic is more centralized than it would be had I do it in a BI tool. So creating multiple shapes of data is really easy in a sense. And then I just want to go back to show you how the automation really pays off. If I go back to the publisher of this data, so this mesh domain weather data that I published out of this flow, I can come in here and I can make an edit. Let's say I'm changing business logic and I'm saying maybe rainy days are only 1.5 centimeters of rain. So I have less rain required to call it a rainy day. So I'm changing our business logic here. The challenge for non-automated pipelines or imperative pipelines is that if I make a change like this, if I make a change like this, I don't know how to propagate the change downstream. I'm a human, so I need to figure that out. Ascend is not only going to propagate this within this flow, but if I were to go to the downstream flows that are subscribing to this, you can see that propagation is going to happen all the way downstream. So I can have any number of dependent components downstream. The automation for Ascend is going to help to not only help, but actually do the work to figure out what it needs to update and how the data needs to flow. In this case, I changed a business rule that changed an entire data set. So it's going to flow everything downstream for all dependents. That may not be the case in other data sets or with other particular transformations. So with that, the basic build is complete, Paul, and I went pretty fast, so hopefully people can keep up. If you didn't, of course, you can always get a copy of the video and follow it again later. But we also have the documentation online here, like I showed you how to get to that that you can use on your own time to recreate the scenario and see how easy.
Yeah, that's awesome, John, and thanks for running through that. I didn't want to interrupt the flow, but we have had a couple of questions come through. So the question is, where is the compute happening? Is it happening in Ascend? Is it happening in Databricks? And the answer is it's all pushed down into Databricks, right? Mm-hmm. So when you connect to a Databricks cluster, Ascend acts as the kind of control plane manager layer of all of this. So it owns the logic and it kicks off the right jobs, and it connects to the S3 buckets and ingests the data. But all the data is landing immediately in Databricks, and all the processing happens in Databricks as well.
Yeah, and I think that question had a little snowflake angle too. So if I were to subscribe to data from, let's just grab some snowflake data here, like this, for example. I have no idea what it is, but I'm going to subscribe to it. This data is coming in from Snowflake in a continuous data share. So as records get updated or schema gets updated, it all crosses over. The compute on the Snowflake side gets consumed when we pull data out of Snowflake. There's a tiny bit of compute for that select statement. And then there's compute on the Databricks side, obviously, to write the data into Databricks. Databricks is responsible for that compute. Ascend isn't really doing any appreciable work in between those two, other than some logic for figuring out schemas and that kind of stuff and publishing to a catalog. But the compute is how you might think about it. If you understood that the data is coming from Snowflake, of course, there's a select query, and if it's going into Databricks, there's a copy into or an insert query, depending. And so the compute is distributed that way. You also get to decide on these components how often to read the data and how often to publish the data. So you can publish updates like once an hour, but if you only want to consume data once a day, you can consume data once a day. I get a refresh from your source environment to your target environment, and those can be a separate schedules to meet whatever need you have for those kind of updates.
Yep, that's great. Yeah, so I guess the TLDR is that the compute happens on whatever data plane that the data flow you're working on is running in, right? So even if you're pulling it in from another place, you're literally landing it into your data plane of choice, your data cloud, and then you're doing the work there, and that's great.
And then I think
so
there was a follow-on question too about
I was
storage and stages and things. So Ascend tries, just in general, Ascend tries very hard. So the question is, what happens to the data? Does it go through Ascend? How does it get stored before it goes into Databricks when it comes out of Snowflake? Just in general, Ascend tries to be as ephemeral as possible. So we are not a database. We don't store stuff. We don't want to either see the data or take responsibility for the security of it. So we don't do that. What does happen, however, and it depends on the environment, which cloud you're running in, or whether you're in Ascend Cloud or in GCP or in Azure or AWS. But in general, there's a staging environment for each of these data planes. So Snowflake has a staging environment. Databricks would have one. The data would then leave Snowflake, in this case, for example, and get staged into a private bucket area for Databricks, and then get loaded into Databricks, and then destroyed out of that bucket. That bucket is, depending on whether you're a dedicated deployment in your own tenant, that bucket would be owned by you. If it's in our cloud tenant, then that bucket is still namespaced and secured for your particular compute environment. But that bucket would obviously be in a location that Ascend has set up for you. So there's a little bit of data that we store, but in general, we try and be as ephemeral as possible and not store any data.
Awesome. And I guess one other question, John, that we usually get when we look at this kind of a setup is, it's amazing that when you make changes, they're automatically propagating downstream. And as you demonstrated, when you make a change, it can flow through a pretty complicated system network of pipelines. What happens when you don't want to do that, though? What happens if you're just like making a few changes and you want to see what happens up until a certain point?
Oh yeah, sure. And that's a really common use case where we'll just take the example I have up here right now. If these are tables that end up in your reporting tools, and let's say you only want to publish reports once a day, like at midnight, for example, a common scenario would be to pause the upstream component. We have Ascend builds in transformation level granularity for what you stop and start. So it's rerunning an entire pipeline or not running an entire pipeline those aren't real concepts in Ascend. We view every single partition as a separate executable body of work. So we do allow users to pause components. And that means, like, if I were to edit something upstream, so if we just go back and undo what I did before, for example, and we make an edit here in our weather data, and let's say we want 1 centimeter this time of rain. We'll go ahead and make it changes and propagate it downstream, and we're just going to go back to where we were. And then as the changes happen, they'll stop at this component. So that means that a couple of things are happening. One is I'm able to process the left side of my data flow continuously throughout the day. For example, I can ingest data. I don't have to hold off on ingestion. I can be ingesting and processing rules and troubleshooting and doing all that work on the left side. And then if you have an external orchestrator, for example, let's say you have some business cases where you want to trigger some report run or something, and you need the data to be updated before that report run, then you would simply use our CLI or SDK or API to unpause a component then and execute from downstream. So Ascend really lends itself to allowing you to have your cake and eat it too, which is the cake is I want to process and ingest data spread out throughout the day. And when my smart people are in the office at normal business hours, I want to get all that work done. But then I still want my business to see reporting data that's valid as of midnight or whatever, 6 in the morning or whatever your business scenarios might be. And then you can publish different shapes of data again into your reporting tools to make that even simpler. Start to pull business rules back from your BI tools and start to use Ascend's automation to keep all of this up to date. Again, some of this data is duplicative here. So this all rides data is duplicated in the good part and the bad part. But because Ascend is managing all of the automation for keeping everything in sync and up to date, that's not a problem. So if your reporting environment can be simplified because you can consume these shapes differently, then by all means, you should do that using Ascend because we can keep it up to date and you have confidence that the data is correct. Notice 800,000 plus 4.1 million equals 4.92 million. So
That's great. Yeah, thanks for that, John. One other question came in. So how do you store the definition of the flow for version control?
Oh, yeah, great question. So the broader question is how do you do CI/CD processing and how to do automated deployments and that kind of stuff of data flows themselves. We provide a really flexible integration strategy. We can integrate with GitHub, GitLab, Jenkins, you name it. Any CI/CD platform can be integrated with Ascend. And the way that integration happens is through a CLI. So we have a command line interface that wraps our SDK and API that makes it really, really easy to pull an image of the flow down in a human readable format that's really easy to source control with Git. And then you can do merge requests, pull requests. You can do all kinds of sophisticated software engineering with your pipelines. And then you can actually publish pipelines and target different environments. So you can take a pipeline from dev and promote it to UAT using your CI/CD process and your built-in control points, whatever you might have for that. And then in the CLI script, you would just add some Ascend CLI commands that push the flow out. And the same to go to production as far as publishing entire platform, or you can publish a data service, you can publish a data flow, and you can publish individual components that way. It's a very simple integration. In fact, if you follow our Rapid Start program with a field team, one of the very first things they do is help you set up a CI/CD process for your data flows because it's that important to us, and we know that it's a best practice for you.
Yeah, and it's actually very popular with a lot of the developer community that you can edit your pipelines in either form, right, John? So you can write entire pipelines as code if you want to from the back end and upload those, and then they'll show up in the UI, and vice versa. You could take this data flow, you could drop it all out into code and edit the code. You can edit each one of the transformations individually. You can edit the YAML file and the definitions of the flow and the relationships between the two. And all that stuff, it happens on the back end as well. So
yeah, we have customers with over 15,000 pipelines, and I assure you, no human created those. They are scripted and automated with our SDK and CLI capabilities. So as much as Ascend is a nice user experience, it's also an amazing automation experience for actually creating things and moving things and adjusting things. So doing like massive schema changes or adding transformations or inserting new things into data flows, that can all be automated and scripted for sure.
Another question came through, John, about lineage. So what kind of lineage exists beyond a single data product? Is there a higher level view at sort of the catalog level?
Sure. So because of our level of automation that we support at Ascend, one of the side effects of that is that we actually need to understand the lineage in detail in order to achieve the level of automation that we're looking at. So I'm about to pull up one of the human views of lineage. This will be table level lineage that you can see how the data flows through your system. So this is a single data flow. The length of the bars is in bytes, or sorry, in record counts. I can change that to bytes if I want to see how many bytes are moving between flows. So I can understand like, hey, this data is leaving. Where does it come from? This is the human view. You can get a programmatic view. So if you have to ask complex questions like, when was the data ingested for this particular outcome? Programmatically, we can tell you that. There's not a great way to do that from a UI perspective. But then I can start to zoom out and I can see lineage. In this case, this is lineage for the entire data service that I've selected. And you can start to see how data flows might interact. So some of this data down here is interacting with a different data flow, for example. And again, this is a human view of the world. But this is useful to talk through like, hey, this is my data set that I care about. Where did it come from? And can I follow it to the beginning and sort of see from a human way, like, how do I get to this? And where did it come from? And then, of course, programmatically, if you want to create reports for this, Ascend can use its own SDK to create reports. So if you want, an ingestion report that tells you, give me all the files for this particular outcome, Ascend can tell you that in a programmatically automated way for sure. So,
yeah,
great question.
Great.
Lineage is one of my favorite topics.
Yeah, and it's also true that we integrate with native functionality to help with this as well, right, John? Like we mentioned at the beginning, Unity catalog. So if you set up a catalog.
Yeah, when you put your catalog together, the catalog will track the lineage also, so you can use the ascend tools, um, so that you can see how Databricks view of the world is. The caveat there, however, is that the ascend lineage actually crosses data planes. So if you have ascend on Snowflake and you have ascend on Databricks and you have ascend on BigQuery, we can actually show you the lineage across all three of them. Databricks lineage is only what Databricks sees, which is only its own environment. It can't see the lineage across, and it also can't see where the data came from. So the file that got loaded, for example, it sees the tables and it sees within Databricks, but it doesn't see like how that data was loaded and what type of file it was and when it was loaded, like all that kind of stuff. So the Ascend lineage is definitely an enhancement on top of the things that Databricks is working on for Unity Catalog. As far as lineage over time goes, which is the next question on this, because you can version your data flows, you can actually see how your data flows are changing. This particular view of the world doesn't have a like compare to last month capability yet. That sounds interesting, and it sounds something we would consider for our roadmap if it was useful. So from a versioning standpoint, absolutely, you can have version pipelines and you can see what your pipeline was last month and you can see what it is this month. As far as visualizing the lineage, though, we don't currently have that capability. We can see point in, as of right now, lineage is what you can see, basically the runtime lineage.
Yep. Great questions.
Mhm.
Yeah, so we got a really engaged group today. This is awesome. But yeah, it's been really great to kind of run through all this and actually see it working live. That's one of my favorite parts of these sessions is that we're not just going through slides, right? We're actually doing work and we're showing how things happen,
Mhm.
getting super hands-on, helping to support folks that are trying to follow along as well as best we can.
Yep.
Um, so yeah, I think we can go ahead and wrap it there. So thanks,
Oh,
John,
great.
for everything. Thanks everybody for joining. If you have more questions, because these have been great questions, please feel free to submit any more questions to us on our website, send.io. You can request a personalized demo and spend a little bit more time going through what your particular use case might look like. You can also get started with a free trial of our software, or even just a free version of a stripped down version of it running in the cloud. If you have questions, you can ask questions via the chat in the product there. And we really appreciate your time, and thanks for joining. Thanks, everybody. Have a great rest of your day.
Thanks.
Bye-bye now.